Okay, for our do now today, we're basically matching factoring problems with the factoring methods down here. So number one, 4x squared plus 36x, this would be GCF extractions. So B is the answer there. The greatest common factor, by the way, is 4x. Number two, r squared plus 7r plus 12. I hope you realize that the invisible coefficient of r squared is 1. So therefore, a equals 1. So that would be option D, trinomial a equals 1 factoring. Number 3, a is 25. So here we have trinomial factoring with a is greater than 1. Number 4, 4k squared minus 9. Well, 4k squared is a perfect square, and 9 is a perfect square. And we have a minus sign between them. That's a difference of perfect squares. And lastly, here we have 4 terms, and we of course can factor this by grouping with parentheses around the first 2 terms and parentheses around the last 2 terms, GCF extraction, and then extract the binomial GCF. Okay, so to get into the proper mindset for today's lesson, I want you to take these old-fashioned numeric fractions, we'll call them integer fractions because they're all composed of integers, 12 over 20, and instead of doing it the old-fashioned way, which is, factor out the, or divide by the greatest common factor, I want you to actually factor to its prime factor. So 12 can be broken down to 3 times 2 times 2, and 20 can be broken down to 5 times 2 times 2. And then I want you to cancel out identical numerator and denominator factors. So the 2's cancel, you're left with 3/5. The second one, 5 is already prime, and 16 can be factored down to 2 times 2 times 2. As you can see, nothing can be canceled out, so we'll put it back together as 5 over 16. That is in simplified form. 15 can be broken down to 5 times 3, 65, 5 times 13. The 5's cancel out, we're left with 3 over 13. 14 over 18 can be broken down to 2 times 7 and 2 times 3 times 3. As you can see, the 2 and the 2 can cancel, thus leaving 7 over 3 times 3, which is 7/9. 50 is really 2 times 5 times 5, and 70 is really 2 times 5 times 7. So we can cancel the 2's and the 5's, leaving 5 over 7. And finally, 9 over 24 can be factored to 3 times 3, 3 times 2 times 2 times 2. So 3 over 3 cancels out. We're left with 3 over 8. So essentially, rational means in the form of a fraction. So to simplify rational expressions, we must factor the numerator and denominator, then cancel out any common factors that are both in the numerator and denominator, exactly like we did with the integer fractions. So what we're going to deal with today are fractions, but with polynomials in the numerator and denominator. So here we have trinomial, we have a binomial down here. And because we have spent so much time warming up with factoring, this should be almost second nature to you that I can factor this trinomial in the numerator to x minus 5, x plus 3. And also the denominator, x squared minus 9, you should instantly recognize that this is a difference of perfect squares. It's x minus 3 times x plus 3. We can cancel the x plus 3 and the x plus 3. We are left with x minus 5 over x minus 3, and this is our final answer. A lot of students want to do this. They want to cancel the x's, but that is very illegal because the x and the 5 are joined by subtraction. In other words, whenever the terms are joined by addition or subtraction, you cannot cancel. If these were multiplying each other, for example, if it was negative 5x and negative 3x, then yes, you could cancel the x's. But this is the final answer. Looking at example 2, we're going to extract the greatest common factor of x, leaving x plus 7. So the numerator is x times x plus 7, and the denominator x squared is x times x. We can cancel the x with the x in the denominator. Final answer, x plus 7 over x. Number 3, I noticed that there is a greatest common factor of 5. So that leaves 5 times n squared minus 6n minus 7. And I can factor by using the x method, which we're looking for 2 factors that multiply to get negative 7 that add to get negative 6, and I know that will be negative 7 times 1. So therefore, our numerator is now 5 times n plus 1 times n minus 7. The denominator has a GCF of 10, so I can take that 10 out, and I'm left with n minus 7. Now, if we look at this large fraction here, we have n minus 7 and n minus 7, which can be canceled out. Also notice that we have a 5 and a 10, and this 10 is really 5 times 2. So there's my 5 times 2, and as you can see, the 5s cancel out, and the 2 remains. Therefore, the final answer is n plus 1 over 2. Number 4, here we have a difference of perfect squares in the numerator that can be expanded out to x plus 2, x minus 2. And x squared plus 8x plus 12 is simple trinomial factoring that is broken down to x plus 2, x plus 6. X plus 2's cancel out, and we are left with x minus 2 over x plus 6. Okay, I wanted to look at one last example, Sage and Scribe number 4. And this is quite a bit of work because I noticed that I cannot extract a greatest common factor from the numerator. I cannot extract the greatest common factor from the denominator. And I also noticed that the leading coefficient, in other words, a, is greater than 1 for both of these. So I'm going to resort to splitting the middle term method, which is when you take 5 times 24 and you list the different factors that give you 120. And we're looking for, because c is negative, we're looking for the factors that when you subtract give you 26. So 2 times 60, 3 times 40, 4 times 30, and isn't 30 minus 4 26? Yes, it is. So we will split the middle term, 26a, to 30a minus 4a, and then factor by grouping. So in other words, I've taken this problem and I've kind of taken a detour so I can work on the numerator here. I can factor the numerator here, and then I will factor the denominator here. And then once I get my factored forms, I can put them back up here and cancel what I need to cancel. So let's proceed with this one. We have factoring by grouping, which we can extract the 5a, that leaves a plus 6. I can extract negative 4, which leaves a plus 6 as well. The a plus 6 and the a plus 6 match, so I know I've done this correctly. And my final factored form is a plus 6 times 5a minus 4, so we'll put that answer up there. Now let's work on the denominator, which is 2a squared plus 13a plus 6. 2 times 6 is 12, and I'm looking for factors of 12 that add to 13. And since c is positive, we're adding. So we have 1 times 12, 2 times 6, 3 times 4, and it was actually the first 1 times 12 because they add 1 plus 12 is 13. So I've gone ahead and set this up like grouping, split the middle term to a plus 12a. I group over here, I extract a to leave 2a plus 1. I extract the 6 to leave 2a plus 1. I have matching parentheses, matching binomials, so I know I've grouped correctly. And the final factored form is 2a plus 1, a plus 6. And as you can see, It worked out very nicely because a plus 6 can be canceled out both in the numerator and the denominator, thus leaving 5a minus 4 over 2a plus 1. And that's how you simplify rational expressions using factoring. Good luck to you.